Okay, welcome everyone to this meeting of the virtual IMS user group. Thank you for joining us. And just to let you know that our very first meeting ever was 15 years ago in December 2007. So 15 years we've been holding these meetings. I'm Trevor Eddles. I'm CEO of iTech Limited. We're a mainframe consultancy, analysis and technical authoring organization. We're responsible for the content on the virtual IMS website and for producing the newsletters. And just a reminder, if you're looking for our website, you can find it at itech-ed.com/virtual IMS. Let's let some more people in. Just give me a second. Right, so here's the agenda for today. As usual, most of the meeting will be taken up with a presentation, and today our guest presenters are Joseph Leamon, IMS Software Engineer at IBM, and Mahmood Abuzaina, Software Engineer at IBM, and their talk today is entitled Distributed Access to IMS via Java. And a copy of the slides from the presentation will be on our website later today. And if you missed any of our previous meetings, you can download copies of those presentations from our website. And you can also listen again. Our resources page then has all that information. So after that, any questions, then news, articles and blogs, and then we'll talk about coming soon. And the whole thing, I anticipate, will last for about an hour. So let me just admit a few more people. Whoops. Okay, so anyway, as I just said, today's presentation is from Joseph Leamon and Mahmood Abuzaina. Joseph is an IMS software engineer focusing on providing support and new functions for the IMS universal drivers. Joseph graduated from San Jose State University and has been working at IBM for over 7 years. Mahmood is a software engineer at IBM. He's been working with IMS for around 5 years, where his main focus has been on the IMS Java universal drivers. He graduated from San Jose State University with a BA in software engineering. So let me stop sharing my screen. And Mahmood, I'd like to thank you very much for being with us today. And what I'd like to do now is pass control of the meeting over to you. So if you're happy to share your screen, you can start.
Thank you, Trevor. Let me share my screen.
Oh, sorry, before you start, one more thing to say. If you've got any questions, if you can just type them into the chat, please, and then I'll ask Mahmood or Joseph later at a suitable time. Right, thank you. Mahmood.
Okay, thank you everyone for joining. As Trevor mentioned, we'll be discussing how to access IMS from distributed applications using our open database environment and universal drivers. 1 second. Okay, so Trevor already did a proper introduction. Thank you for that. But if you ever need to contact us, there's our emails right there. Feel free to ask us any questions. So for the agenda, I'm gonna be mostly discussing our open database environment. So we're gonna go over an overview and then talk about some system side configuration. And then we're gonna get deeper and try to understand the OpenDB communication flows. We're going to also discuss high availability and how to set up that. Talk about some PSV considerations, and also we're going to be looking at some Java applications and just show you some examples. And finally, we're going to be discussing IMS database metadata and how we actually use that for our universal drivers. Okay, so starting off with the overview. So basically, open database is an environment where it allows access from distributed applications and systems into IMS from basically anywhere in the enterprise. So customers have been using this environment for their distributed applications to access IMS directly. Some analytic tools have been that use this environment to also access IMS data. So this helps data analysts to inspect, resolve, and maintain data. Also, DBAs and system programmers and application developers can have a better insight into IMS schemas and metadata using various tools that we provide. So this is an overview of the open database components that you typically need to start using Java to access IMS. So starting from the left side, we have the IMS universal driver, which the Java application typically uses, and that would send some data over TCP/IP to IMS Connect. IMS Connect then would grab that and route it to ODBM. And ODBM is basically grabs the DRDA flow, which is our database communication protocol, and it actually sends the DL1 calls to IMS. So that's going from left to right, and then IMS would obviously send back data, and it would go back the same way. So it would get packaged in ODBM over to IMS Connect, which sends it back to the Java client. Some system side configuration. I'm gonna go quickly over the components and how to set that up. For the infrastructure, IMS, first of all, must be in an IMS Plex. And then you would have to have the SCI, the structural call interface, which is a common service layer address space, and it is what enables intercommunication between IMS components. And then there's the OM, Operations Manager. And you would typically need this if you want to issue and process commands to various IMS components.
Mahmood, I've got a question from Mike Brauweiler. He says, can ZOS Connect be used instead of IMS Connect? Or ZOS Connect rather than IMS Connect?
No, I believe IMS Connect. Correct me if I'm wrong, Joseph, but I think it is just IMS Connect is the main gateway.
Yeah, you're exactly right. IMS Connect is just a TCP/IP gateway. So, I mean, if you're using ZOS Connect, you would need IMS Connect to go through TCP/IP. So they're two separate things.
Okay, thank you.
Okay. Then you would need the Open Database Manager, ODBM, and that's actually what processes the distributed requests and sends them over to IMS to access IMS data. IMS Connect is basically the TCP/IP gateway. So it basically routes those DRDA flows over to ODBM, and you could have multiple ODBMs, so it does the routing and sends the DRDA flow for to ODBM. And finally, we have the IMS universal drivers, which resides on the client side, and that gives the client APIs to be able to send requests and access data from IMS. Okay, so starting off with the SCI, so here we're just looking at some JCL proc and just showing you how to configure and get started and how to start the address space. So first, we have a request. We request a base primitive environment, BPE, configuration member. And in this case, it is the suffix is 001. So we insert it here. And then we also require a SCI initialization member. So that member would be CSL-SI, and you would have a suffix number. So in this case, it is 001. So it goes and so first looking at the BPE config member. Something to note here that this config member can be shared by all components, whether it's SCI, OM, ODBM, or IMS Connect. So first here, we're just setting trace levels for the different components. Also, if we can set up, we can set the option to whether to offload the work onto zip processors instead of general. So this is where you would customize that for example, here for IMS Connect or ODBM. So looking at the SCI initialization member, you would have to obviously specify a name, in this case, SCI1, and you would tell it which Plex name it should join. And finally, you would issue the command of start SCI1. Okay. For OM, it looks pretty similar. So in this case, we're using the same BPE config member, and we're calling CSL OI001 for the OM initialization member. And inside the initialization member, we're setting the OM name, OM1, and the Plex name for it to join. And finally, we start with this command, start OM1. So after we have SCI, and it has established an IMS Plex of Plex 1, now we can let IMS join that Plex. So inside the DFS DF config member, you can go and look into the section common service layer, and in there you can specify the IMS Plex name. So in this case, Plex 1.
Sorry to interrupt you again, but we've got a
Mhm.
comment from Brad St. Pierre. He's saying that my perception is that ZOS Connect is a TCP/IP alternative to IMS Connect. It connects locally on its LPAR to multiple ZOS resources, including DBMS, DB2, IMS. Do you or Joseph want to comment on that? Oh, but before you do that, Anders Olberg has just said IMS TCP/IP gateway is IMS Connect. ZOS Connect talks to IMS Connect. Right, which is what you said earlier, isn't it?
So I think we're talking about two things, like using it on the same LPAR. In that case, yeah, you are bypassing IMS Connect because you're not using TCP/IP. But if you're off the LPAR, then you would be using IMS Connect.
Okay.
And
Yeah.
that's the distinction here.
Right. Thank you.
But yeah, I'm not a ZOS Connect expert, so it's my understanding.
Okay.
Yeah. Thanks.
So moving on to the ODBM. So again, we're using the same BPE config, and it requires an initialization number again. In this case, CSL DI001. So looking inside the initialization member, we set up the ODBM name, in this case ODBM1. So another thing for ODBM, you need the ODBM to point to an ODBM config member. So that's another member that you need to point to. And also you need to specify the plex name to join. So over here, you could also specify RRS, whether it's yes or no. So next slide, I'm just gonna briefly explain RRS. So basically when RRS is yes, ODBM communicates with IMS using the ODBA interface. It is similar to ODBA applications that run in DB2 stored procedures that access IMS. And it is required when you want to do global transactions and two-phase commits. When you set RS no, basically that uses the DRA interface, similar to KICS to DB control environments. And in that case, you will not be able to use global transactions. Okay. Okay, so this is the ODBM configuration number. So on top, you can set some parameters for fastpath buffers. For example, here also you can set max threads, basically the max threads that ODBM can have. In the local data storage configuration, you're setting up the ODBM name, and you're setting up what basically IMS is going to be talking to, data store, and in this case it's IMS1. And you also have the option to set an alias. It can be the same as the IMS ID, or you can give it a unique alias. And here we start with the command for start ODBM1. And this is what it looks like when it starts, connected to IMS data store, IMS1. And then we have the IMS connect. Same thing, we have the BPE config number. And then we have the HWSCF config number for IMS Connect. So we go and customize that one. Inside here, we set an ID. In this case, the ID is HWS1. We set up whether we want RACF security or not, and also we set whether we want RRS enabled or not. And finally, we specify the Plex name, Plex1. So inside the IMS configuration member, we also over here we specify the port ID and port timeout. So in this case, it would actually create a port with this number 5555, and the timeout for this port would be 6,000, which is hundredths of a second, which is basically a minute. And also we have a timeout for ODBM in case there's long-running queries, so it runs out and times out. So same thing here, we start the IMS Connect, and we get back that it's connected to the data store and the Plex. And finally, we have the universal drivers. Usually we ship the universal drivers in a jar, and that's what the client application use. And it has two main interfaces or APIs. The first is JDBC, which is the standard for Java for accessing databases. And then we have the DLI interface for people that are more comfortable with the DLI and want more granular control over what they get back. IMS also has resource adapters. So we have two that we actually recommend that use JDBC interface. The other two uses the CCI, common service layer, common client interface. JDBC is usually more popular, and that's the one we actually recommend. So if you're using single phase commits, you would use the first resource adapter, and if you need two phase commits, you would use the second one. So all of these parts are shipped as part of the IMS Java FMID of JMK XX06, where XX is the IMS release level for, so like for level 14 or 15. And this, so the universal drivers come with the base installation. There's no extra charge or subscription needed. So as mentioned before, you can obtain the drivers via SMPE installation using the FMID. Also, parts are also available in the ZOS Unix system services under the path user/lpp/ims/ims Java. You could also download from our download site, ibm.com/ims. You can find the resource, the jars and the resource adapters there. Finally, we also have a Maven repository if you choose to get the drivers from there. Okay. Do we have any questions, or should we keep on?
Sorry, move on then, Mahmood.
Okay. So now we're gonna go and try to understand the communication flows between those components that we mentioned earlier. So this is the overview of the communication flows that happens between the Java client and IMS Connect, ODBM, and finally IMS. So we're gonna go deeper section by section and just show you how that will look like. So IMS universal drivers, we have a logging and we trace the DRDA communications between the client and IMS Connect. So one of the things that we trace is network time and the server time. So network time is how long it takes to write and read the bytes to and from IMS Connect. And server time is the time spent waiting on response from IMS Connect. So there are other tools that could show you the DRDA flows that reside on IMS Connect. So one of those tools is IMS Connect extensions. We can basically capture the DRDA and the ODBM routing exits and such. There's also the IMS problem investigator, which is a merged view of the IMS Connect DRDA flows and IMS and the IMS logs. And also there are other tools that the vendors do have and offer. So starting off, with a Java client, I'm gonna be later on showing a Java application example. So typically we first get a connection on the Java side. So we do a get connection call, and that establishes and opens up a TCP/IP socket to IMS Connect. And then after that, some handshaking goes on where server attributes are exchanged and some what type of security is best passed on, and what data store you want to talk to, and that sort of thing. And IMS Connect then returns back the server attributes and all of that, and the levels. So this is what it looks like in our trace. So here we have this is what we're sending, send buffer. So first we have the exchange attributes. Basically you're sending over what you're compatible with levels wise for icon and ODBM. And you're also sending what security checks are in place. And you're getting back from IMS Connect the icon and ODBM levels. And so after that, what we do is some security check. So you send over a username, a user ID, with the password. Obviously, it will be encrypted here. And if everything is good, you get back that everything is fine and no errors. So on the Java application side, after getting the connection, you want to start executing SQL statements. But before that, we need to grab metadata from the IMS catalog. So first thing that happens is we allocate a PSB, and that request first goes to IMS Connect. IMS Connect decides which ODBM is going to route to. And ODBM is going to then request IMS to schedule a thread for the PSB. And if everything is good, then it's going to come back as successful to the application. Second, we do an open query call with a DLI GOR call issued against the IMS catalog, and that basically returns XML format of the metadata that resides in the catalog. And that metadata is basically what describes the PSB and DBD that we have for that PSB. So over here, we see that we're allocating the PSB. In this case, it is BMP 255. And that gets routed to a data store with an alias of IMS1. This shows the DRTA flow for open query. So over here we're issuing a GUR DLI call against a catalog PCB, which is called DFS cat 00. And in the SSA list, we're basically saying I want to return the metadata for this PSB. So here it says PSB BMP 255. And this is how it comes back as XML. So obviously, if this is cut off, it would be much longer. But this is typically how it would build and send it back as XML.
Mahmood,
So,
sorry, before you go on, I've got another comment from Anders Ornberg. He says IMS COS Connect always talks to IMS Connect. You can do a REST call directly from an MPP to COS Connect if POSIX open bracket on close brackets is set. I just thought I'd share that with everyone.
okay, thank you. Okay. So after grabbing the metadata, we actually go ahead and cache the metadata on the client side, so we can use it later on when we're processing our SQL statements. So after that, we get to the stage where we actually want to process an SQL statement. We do another open query call, and that goes to ODBM, which then interprets that and calls a get unique and get next calls from IMS. So depending on the fetch size, so the default fetch size in our driver would be 0. So that basically says just get me as much records as possible, but you can specify a specific number from 1 to n, depending on how many records you want back on a single call. So after the get unique, if there's more records to be retrieved, then it would loop some get next calls until all the records are fetched. So if there's more, it would do the continue query calls, and if we have reached the end of the records, we would get the end query, which says no more records are left. So this basically is showing the open query flow. So in this example, we have the DLI with an SSA list that looks like, I'm not sure if you can see my cursor where I'm pointing to, but basically here we're basically calling on to the hospital database with this SSA list using the PCB01. So we do a DLI function of retrieve NH, and this is how we construct our SSA list. So this becomes useful when looking at the trace and seeing how our driver how it interprets the SQL call into DLI. So finally, at the Java client, you do a connection.commit, and that sends a commit request. And if everything is good, then the commit is complete and sent back. And this is what it typically looks like. Also, when you do connection.close, the PSB gets deallocated, and if the allocation is complete, you get back this flow. Okay. Any questions?
No, there's no questions coming up. If you'd like to press on them, Mahmood.
Sure. So for high availability, we're going to talk about how to account for high availability and not create any bottlenecks and hinder performance. So it's important to take into account high availability. So the key concepts is that IMS Connect can communicate with one or more ODBMs, either on the same LPAR or different LPARs within the same sysplex. ODBM can communicate with one or more IMSs within the same LPAR, and multiple ODBMs can communicate with a single IMS.
Sorry,
Um,
Mahmood, I've got another question. How do we maintain security?
Security from the application to IMS Connect. Is that?
Yeah, I'm not sure. That's all the question says. How do we maintain security? Application from Java, yes.
So as long as you are using SSL for your TCP/IP connection, that should secure your TCP/IP. I hope that's the answer you're looking for.
Okay, thank you.
Thanks. Okay. So, okay, customers who implement high availability, they use sysplex distributor to load balance the TCP/IP communications from the client applications to IMS Connect. IMS Connect routing, basically routing exits basically determine which ODBM the IMS Connect is going to talk to. And a general rule we have is to have at least one ODBM for per IMS control region. So this gives a better view of what we were discussing. So basically on the left side, you have multiple application servers that are sending TCP/IP requests, and the sysplex distributor is what maintains the load and the balance and decides which IMS Connect to send to. So IMS Connect, as we can see from this chart here, can communicate to different ODBMs across LPARs. However, ODBM can only talk to the IMS that resides on the same LPAR. Okay, so some PSP considerations.
Sorry, before you move on to that, we've got another question. He says a related question would be, how do we control access to IMS Connect itself, e.g. log on, LP, number, etc.?
I believe you would have, there are multiple user exits for that. If Joseph, you have more information.
Yep, sorry, I was muted. A little outside my area, but I think users can just be, RACF authorized, and I mean that would provide a lot of security. I can look more specifically into that.
Okay, thank you.
So, okay, so some considerations for the PSP. We do require that it has a PCB name or PCB label. So the OpenDB solution uses the AIB to DLI or AER to DLI interfaces, which do require the PCBs to be referenced by the PCB name or label. And also something to consider is to have the appropriate level of processing options, the proc opt for the distributed applications to use, and having the appropriate levels can reduce locking and limit access to the database, and only limit updates when necessary. And also ensure that the PSB is secured under the appropriate RACF resource class to limit access and audit and account for access to the database. So moving on to Java application examples. So as I mentioned briefly before, we do have two APIs. The first is the JDBC, which is more widely used and people are familiar with. And we have the DLI, which is what IMS users might be more comfortable and want to use when they want more control of what kind of DLI is sent over. So this is a JDBC application. We first want to get a connection. So to do that, we get a data source object, and we set the server, the host name, and we set the port number. This is the IMS Connect port number that we previously set when we configured IMS Connect. And we set the data store name. This is the ODBM alias that you want to route to. And we set the database name, which is really the PSB name. In this case, BMP 255. And then we set the driver type, which is 4. And this basically is just telling the driver that we're accessing IMS from a distributed environment. And then we set the user and the password. And finally, we get the connection. From the connection, we can create a statement object that we later use to execute a query, SQL query. So in this case, we're selecting fields from the hospital database where hops code equals that value. And that returns a result set object. From the result set object, you can get metadata about what you got back. So we do a while loop for the result set .next. So so that gets us the next record, and from the result metadata object, we can tell how many columns there are and what the column names are. And using the result set object, we can, for example, here we're getting the string back, depending on the data type. We have get string, get integer, get depends on the data type. And then after after you're done using these objects, it's a good practice to close. So here we're closing the result set and the statement, and we're doing a commit on the connection, and we're closing the connection.
Okay, a couple more things come up in the chat. Is update activity possible over JDBC calls?
Yes, it is possible.
Okay, great.
Uh,
And sorry, the second one is the set user and set password value in the JDBC app example would be a way of securing the connection and the IMS databases. So that's just a comment rather than a question. But just thought I'd share that.
Right. Yeah. Thank you. Yes.
Yeah, thanks.
So looking at the DLI interface, so this is basically doing the same exact thing as the previous application, but here we're showing the DLI version. So to grab to get a connection here, we use an IMS connection spec object instead of data store. So we set the host and the port the same. So, and the data store and database name would also be the same. So after that, we want to grab a PSB object. So here we create the PSB based off that connection we just set up. And from the PSB, we get a PCB. So you specify which specific PCB you want. And from that PCB, you start building your SSA list. So over here, we're doing the same call, but instead in DLI. So here we're qualifying on hospital, the database hospital, and we're saying return the records that have that match house code and that equals this value. And then after that, we get a path from the SSA list. We get a path, and then we issue a get unique, and that returns some records. And then after that, we issue another while loop for get next to get the other records that came back from the call. And in here, you can do stuff with the data. So here we're getting the value for house code. We're getting the value for house name. And at the end, we do PSB rollback and we close the PSB connection. Okay. Assuming there's no more questions.
No more questions.
Okay. So can I discuss a little bit about database metadata?
Yep.
That we get for the universal drivers. So the universal drivers do rely on the metadata, ideally from the IMS catalog. So the metadata is used to understand the segment relationships and the hierarchy, and whether there's secondary indexes and logical DBs and all of that. Also helps us understand the field layouts within the segment. And it also helps us interpret the the data types for the field that we get. So whether that's packed decimal, zone decimal, date, time, string, etc. Also tells us whether it's signed, unsigned, and the precision and the scale. So we use all that metadata to help us when we analyze the SQL query and convert that to DLI call that we sent over. So basically all of that is done on the client side using the universal drivers where the SQL is converted to DLI. So here we have a typical DBD segment where it has a name of A11111, and it has one field, a key field that's called A1111 as well. So for the IMS universal drivers, that doesn't tell us too much, and that doesn't produce much metadata that's helpful to us. So this would be an example of how that database would look better for consumption for the IMS universal drivers. So here we put more meaningful external names. For example, we put what type of encoding we want for the data type of characters. And we include the missing fields for that segment. Okay. So using the metadata, there's a tool that we provide called E4D. So this tool is actually helpful in mapping out how the hierarchy, what it looks like, and the different segments and fields and their relationship. So all of this uses the metadata. Also using this tool, you can issue SQL queries. And on the bottom, you see here, you get back the results. So this tool actually leverages the IMS Connect on the IMS universal drivers onto the cover. So we have other metadata types that we support. So there's the maps and cases, which is basically, it maps out the different field layouts within a segment. We also support arrays if you have repeating elements in the database. And we also have user type converters. So if you have some custom way of converting the bytes that you're getting, or you want to customize how to write back the data to IMS, you can do that. Okay. That concludes my presentation. If any questions.
Yeah, thanks, Mahmood. If anyone's got any questions, if they'd like to type it into the chat, I'll read them out.
Again, in the meantime, I'll start sharing, and then anyone comes up with questions from either of our presentations, I can address them at the end. Me and Mahmood can. Luckily, my part's not too long, so I won't take up too much more time. Let me show the screen. Okay. Thank you, Mahmood, for the presentation. Just to make sure everyone can see the screen okay. Trevor?
Yes, yeah, that's good.
Thank you. So I'm just going to be going over quickly some of the new features and functions that we've introduced in the universal drivers over the past, I would say probably few years for some of these features. And the main idea is just to kind of show you that once you start using the universal drivers, if you think of something that you need or a function that's missing, then most of these features have come from ideas. So customers have used it, found something they wanted, and opened an idea, and we introduced that that feature. So I'll be going over a few of these, or pretty much everything we've done over the past few years, like I said. So here's the agenda, but we'll go through them specifically one by one. So the first one I want to talk about is the byte buffer API support that we added. So in the examples that Mahmood showed you, especially for the DLI example, everything that we interacted with IMS used an IO area called the path. And this was our implementation, our abstraction of an IO area where we basically provide useful getters and setters to access these fields that you create in your database. So customers have come to us and said, okay, well, I just want to use byte buffers. I want to manage the bytes somewhere else, or do roll my own way of reading these bytes. So let us use the Java byte buffer interface and just put the data there. So we did that. I wouldn't say that there's any advantages to using it over the traditional path. There's just some things you might want to consider. Minimal metadata will be needed to interact with the database if you use this. More flexible manipulation of data, meaning that you're in complete control of the bytes. And if you use direct byte buffers, I mean, this data is technically native, and if you're running on Z, which I know we didn't cover today, you could share this data between other languages like COBOL. Another thing we added is control segment support in the driver. Excuse me. So first, before we get into control segments, what are maps in IMS land? Maps are basically ways you can kind of define fields, and depending on a certain field, certain fields would be valid for certain cases on a record by record basis. So what I mean in this example, we have a map called map1, and it depends on a field called case num. And inside this map, we have two cases, and the case ID is basically the value of the depending on field. And depending on this value, then these cases, either case A or case B, would be valid. So that's mapping. And what we basically added support for is control segment mapping, which basically says, okay, well, this depending on field can now be a field that is higher up in the hierarchy in IMS. So the control segment would be another tag here. And basically how we do this is using the key feedback on a return call to get the value of that field. And so we can map it appropriately. But this does mean that the depending on value, if you're using a control segment, has to be a key field and can't be any other field. And part of this is we added some dynamic case field result set. So really not a really good name, or I really don't know what to call it, but basically if you have this property enabled, and you specify the depending on in your where clause, what happens is that the driver will hide the results that aren't valid. So remember I said case A or case B could be valid. And if you have this property enabled and you specify something that will filter out or make sure that you're using case A, this will be visible and this will all be hidden.
And the default behavior, if you didn't have this property enabled, would have been just having nulls for these fields if you were exposing them. So that was added. We added some SSA optimization support as well. And basically this one is another instance where we take a look at the SSA and we try to optimize it for you. And the real purpose of this is to avoid database scans. So the best way I can show you is by showing you a little example. So let's just take this example. We have a segment with a key of host code, and we have 3 fields in addition to the key called part code 1 through 3. And let's just say that these fields make up the full host code key with their offsets and lengths. Basically, the optimization will take these parts and transform the query into a range query while promoting the fields used to the actual key. And this creates a key search for IMS, and this creates better performance by avoiding scans. So in the example, let's just say we have part code 1 used and 2, that's 2/3 of the key. And then we can replace the last section with with low values and high values and do a range search and then give you the same results. The only difference being that we just made a key search instead of a non-key search. Excuse me. We added hex binary literal support. This is pretty straightforward. In your queries now, you can just use binary or hex literals. This is the supported format. And again, this just lets you use the data as bytes and not have to go through type converters and have Java kind of process the what you meant by a string character data or a date field. We also improved our array support. So the drivers now support dynamic arrays. IMS dynamic arrays are fully supported. In addition to that, we also improved our result set for arrays. So in JDBC, there's a get result set off an array object. And before this support, all of the values would be kind of stuffed into a struct object. And it was very confusing to try to get that data out while you're going through your result set. And so with this property enabled, basically now we can just, we expand those fields out. And so the result set of the array looks a lot more like just a regular result set. All the fields are kind of flattened out. And the last thing, this is coming soon, not here yet. I expect it to be sometime in early 2023, but we're removing our JAXB dependency requirement for the driver. So, I mean, if you're using Java 8 and lower, then you would be, JAXB would be part of it, so you wouldn't notice anything. But if you're using something higher, it's been deprecated, and so you would have to add these libraries, and soon you'll no longer need to have to do that. So yeah, it's highly beneficial for all customers who are mostly using higher levels of Java, I would say. And that wraps up my portion of the presentation.
Okay, thank you very much then, Joseph. We've got one question then in the chat. How to load COBOL copybooks to IMS catalog? Any batch process available?
So I believe E4D can actually, how would you load? So I know E4D can create new DBD schemas from copybooks, and I believe you would use that and have to basically regen the DBD and have your new metadata imported through the catalog batch utility, or catalog populate utility rather, and that would populate the new metadata from the ACB lib into the catalog.
Okay,
So
thanks.
yeah, I think the goal is you would need to get a new DBD to get the that process flowing.
Okay, great. Yeah, the Ashok has said thank you for that. Okay, and I'm going to say thank you. If anyone else has any questions, the slides which had everybody's email addresses will be on our website later. Otherwise, you can send them to me. You should all have something from me with my email address in, and I'll pass them on to Joseph and Mahmood. So that was great. Thank you very much, Joseph and Mahmood. And because we're a virtual user group, please assume at the moment you're getting a virtual round of applause. So thank you. Let me just share my screen and we'll press on. Okay, let's go on then. News, yes, I haven't got any news. Now that new versions of IMS come out 3 times a year, there doesn't seem to be a lot of news. So articles, we've only got one article, introducing the IMS Connect Alt PCB Output Enhancement. Now, that's by Jack Huan and Sanjay Kalia. And you can find that on the IMS part of the IBM Z and Linux One community website. And that came out just at the end of last month. Moving on quickly then, planned for the future, 7th of February next year, we've got lessons learned. IMS application modernization to cloud. And that's Scott Quillisi, who's now Senior Director, Sales Engineering at Precisely. And the other date for your diary in the first part of next year is 18th of April. We've got Dusty Rivers, who's Director of Z System Software at Adaptigent. We haven't actually got a title for that one yet, but hopefully we will do soon. Just to remind you that if you work for a vendor, then sponsorship opportunities are available for this user group. And that's my email address. So if anyone wants to contact me with a question or anything else, that's the address to use. Just a reminder that you can stay up to date with what's happening with the user group and with IMS in general. We've got a Facebook page, we've got a Twitter account, we've got a LinkedIn group, and we're also on YouTube. So if you want to watch any previous recordings, they're all on YouTube. And if you post anything on social media that about us, then the hashtag to use is hashtag virtual IMS. Just quickly, I wanted to mention that we're starting a new user group. January will be the first meeting for the virtual DB2 user group, and that's just mainframe DB2, DB2 for ZOS. But that's our URL. You can find it. If you don't touch DB2, but you've got colleagues who do, tell them about it, please. That would be great. Okay, well, that's it for this meeting of the virtual IMS user group. Can I thank you all for attending? Thanks to BMC Software for sponsoring our user group. And I particularly want to thank Joseph Leamon and Mahmood Abuzaina for today's presentation. So that's it. Thank you all very much for joining the meeting. And I look forward to seeing you all next year on the 7th of February. So thank you and goodbye.
Thank you, everyone.